Douglas Mauro, founder and senior engineer here at TruePath Technologies. I want to again thank Jim and FISPA, not only for having us as a member, but for giving this opportunity to share with you some of the trials and tribulations of sort of DPI, deep packet inspection, and using an appliance that we sell, which is nBox. So I'm going to jump in a little bit about myself. Again, founder and senior engineer at TruePath Technologies. We're coming up to about 10 years here. O'Reilly author, the Essential SNMP book. Feel free to at any time contact me through email, LinkedIn, phone, and cell phone number are on this. And if anybody wants a copy of these slides, feel free to contact me or Jim and we'll take care of you. Quick agenda of what we're going to do today. What is an nBox? We're going to talk a little bit about what that is, what it can do for you. We're going to actually go through the layout of it, some of the features and functionalities. We're going to show you a network layout. We're going to explain how our sort of little lab is set up and how you might have that in your environment today, and give you a quickie on flow and what that means. And then from there we're going to do an overview of the nBox, the GUIs and the features and the functionalities, and then we're going to actually do a denial of service attack on a local web server of ours. We're going to actually inundate our test web server with a whole bunch of traffic and downloads, and you'll be able to see that with the tool, and we'll be able to show you some of the alerts. So really the goal of today is to educate you just a little bit on how this sort of appliance can help you see what kind of traffic. A lot of telcos and enterprise companies out there, like, they just don't have a feel for that. What kind of traffic? Sure, we know it's a 4 gig and we're at 72%, but who's doing web, and how many people are going to Facebook, and how much Dropbox traffic is this group doing? And this kind of appliance and this kind of deep packet inspection will allow you to see that and alert on it when somebody starts using a little bit too much. So let's go into what is nBox. Network Traffic Analyzer appliance. nBox is actually a product of nTop, and they're based out of Italy. And this is a project that started many, many years ago by Luca, and a lot of the Linux folks and Unix people may remember nTop as sort of a text replacement to top for your network. Well, that has grown leaps and bounds into not only a great piece of software, but it's actually trickled all the way up into what we're going to talk about today, which is the full-blown appliance. So there's a couple of appliances. There's the nBox NetFlow, which is what we're going to talk about today. There's an nBox recorder, which actually records all of the traffic. So later on you can look at a certain, you can say, hey, what was going on yesterday from 10 a.m. to 11 a.m.? And you can download PCAP files and really hunt around with, let's say, Wireshark. And then there's nTop software as well, like with the nProbe and some of the other softwares that they have there. All of these and prices, and you can purchase them online right from our website. Let's go right into the NetFlow appliance. So what is a NetFlow appliance? People say, well, what is packet capture? What is NetFlow? And we're going to talk in the next slide about what is NetFlow versus sort of a full data set packet capture. But the NetFlow appliance does a couple of things. One, it locally captures packets and it displays them in a nice GUI format, and we'll go into that in a little bit to show you what is coming from to and from and look at the protocols and the number of packets. You can put alerting on it and whatnot. But the other thing you can do is you can point flow traffic. So if you got 10 Cisco boxes out there, you can direct their flow to this appliance and then view that flow. And the other thing you can do is you could actually aggregate all the flow into this appliance and then have the appliance push that flow traffic to some other type of viewer like SolarWinds. So if you have the SolarWinds flow analyzer installed, that module installed, and you have this appliance sitting over the wire somewhere, you could aggregate all your flows in a locally connected network and then push this flow right to SolarWinds. So there's a lot of things that this box can do, but in a sense it captures local traffic, it views NetFlow, and it can forward on NetFlow as well. So let's take a look at the network layouts. The one on the left is what uses what's called a spanning port. So in a switch or a piece of network gear, a router, or whatnot, you can have a spanning port which basically duplicates traffic from one port or a set of ports into that particular spanning port. So if you look at on the left here, we have our network gear and our servers. All of that traffic going to and from that switch are going to be copied into the spanning port there that's going up and down. I'm going to go to a little spotlight here so maybe you can see it here. So all this traffic here is now going to go and be mirrored into the spanning port, which then allows the appliance, right, to now see that traffic. So we don't have to make any physical changes per se. That switch has the ability, and that is a function of the switch. And then the appliance then allows you to then interface it through the management port, and you can get all the web graphs and all the reports and all that good stuff through here. Now, sometimes we don't have the ability to do a spanning port, so we have to do what's called a network tap. And that's really just an easy way of saying a splitter. So we've got the network gear going into the tap, and it goes right to the switch. And really, from a network gear to the switch perspective, this is a complete transparent tap. Even if the power goes down, there are these taps that allow you to still pass through that traffic. So really, there's no single point of failure in here. But what this network tap does do is it copies the traffic off of here. It sort of duplicates that light over this way, again, to the appliance. So we've sort of created this now physical spanning port. And again, same thing. We have it in the appliance. You connect through the web interface, through the management port, and go through that, get through all the graphs and whatnot. So that's how you would lay things out there. Now, the other way we can do it, which we talked a little bit earlier about, is if we want to push flows to this. So here you're going to see our network gear has, let's say it's a couple of Cisco routers. Now we want to push flow to this. Well, we can do that. We can push flow to this, and we can have it within this appliance, and we can even have a spanning port connected to it, and all that's good. And we can interface that and look at the different interfaces through the PC web interface connected to the management port, but we can also export these flows. So we can aggregate all this stuff into this one appliance, and then we can push all of that out into, let's say, a SolarWinds Flow Analyzer. So there are some devices that don't have that ability to do flow. So we'll put this out on a spanning port, and we'll get this flow data, and then we'll push that flow data out to something like SolarWinds. So let's talk a little bit about flow, and this is probably going to be the fastest discussion on flow. But when we talk about TCP/IP packets and all the niceties around it, what we're talking about is the payload. So when we want to record a packet, a lot of the interesting stuff is not just the payload, but what IP it's coming from, what IP it's going to, what port, the timing, all that good stuff. But within a TCP/IP packet, there is also the payload, which actually has all the data. So if you were looking at a web page, that would actually have parts of the web page in it. Well, from a layperson's perspective, flow is really all of that good stuff, but it takes out the data packet. It takes out the payload itself. So we can still have the information. It still contains the information of what IP it's coming from and what IP it's going to and what port, which tells us a pretty good chance of what application you're going to use and all that, but it's a lot smaller because we don't have that payload. So what the devices will do is they'll sort of compress, if you will, all of these data packets, because in the old days the only thing you could really do was just capture all the packets, and that was huge, and that would really gum up the networks out there. So Flow came along, and they had this way to really capture about sort of 90+% of what people really wanted to look at with a much smaller footprint. And that's really what Flow is. So what I'm going to do now is I'm going to switch to the demo. This is the front end to it. You can go in and see the network interfaces, the memory and storage. It's all web configurations. And these come configured, so you just take them out of the box and they're ready to go. What I'm going to do now is fire up the actual web interface to it. So what we're looking at here is the front dashboard. So you'll see this dashboard here, and it sort of gives us an idea of the top Flow talkers. And you'll see we have a couple of people talking back and forth to these different devices. You can see we've got somebody talking on Facebook. If I click on hosts, you'll see the top host send and receive. And you have the ability to click on any of these and dig right into that. And we will in a bit, but for now we're going to look at some of the top client ports, some of the top server ports, and then we get into the applications. Looks like somebody's doing Skype, SSL, some unknown protocols, and we can even look at ASNs and senders. So if we go back, let's take a look, get an idea of flows. So flows sort of come in these little chunks, and down here you'll see this little gauge down here, which is showing us the amount of flows that are captured or being sent in to us, and then a little line chart here. You see that we have 141 hosts. We have about 255 flows. So we sort of get this information, we take a look at it, and if it's important to us, we're going to keep it for a long time. But if it's not, we're just going to sort of expire it out. Think about if we were to put this out into the internet and we say we care about everybody and everything, it would be a never-ending growing database, and it would go on forever, and it would just be filled with garbage, and it would be terrible. So when we set these up for customers, we figure out and say, hey, let's start with, let's say, keeping your local network, your cable modems, and some of your web traffic. And beyond that, we will keep it for 5 minutes or 10 minutes, and then we'll flush it out. And if you want some people to be on there for longer, we can do that. If I click on a device here, you'll see that we bring up a host, and this is the home of it. And you can set custom names for it, and we're going to talk a little bit about the triggers. But here's where you can start to see, like, this IP address is getting this much traffic. And if you hover over it, you'll get an idea of how much traffic it's doing, how much, how little. You can go in here and take actually a look at the traffic, see it's mostly doing TCP. Look at the number of packets. We can take a look at the ports. So what happens is that you get these, let's say, interesting, and it could be good and bad interesting, but you get these interesting hosts out in your network. You know, who are these people that are suddenly starting to do all these drop boxes because they're backing up, you know, online, or what is this unknown? So it gives you a way to start your inspection from one direction or the next. You can actually look at peers here, which is sort of, you know, interesting here, where we can take a look and see which one is talking to this particular one. Look at protocols, flows, talkers. Another interesting one is the geomap. Let's see where this particular user is talking to. And if I go into similarity, you can see some other ones that are very similar to it. I'm going to bring up another one that's a little more interesting. So this is a very active node that we have right here. And it's a great example of, you know, first of all, putting your own IP address in here and seeing the kind of traffic or the places that you go. Maybe when you're running Spotify or Pandora on your machine, it'd be interesting to know where these feeds come from. And again, this is looking at a particular host that I put in here. Searching of the host will automatically complete, and we can run down it. If I look at these alerts, it'll tell me if there were any alerts going on down here. And here's where we can start, and we're going to start talking a little bit about the denial of service and where we would configure the alarms. And this is where we start to configure it. Let's go into historical here. We'll look over the last, let's say, 1 week. I'm going to zoom in a little bit. This server hasn't been up for that long, so. What we're looking at now is all traffic. If I wanted to, as you can see, I can run down and say, you know what, let me take a look at my Dropbox traffic. How much data has been going to Dropbox? Let me take a look to see how much data has been going to DNS or Google or even Spotify. And you can start to see this kind of trend across all the different nodes. And I'll show you in a bit how we can look at all of traffic, not just the host, but for all the traffic for Dropbox for the entire system. Let's go back to another view here. We're going to look at what's called top host local. I'm going to bring up the geomap first. And the geomap shows us where all of these different systems are. And as we zoom in, it gives you more detailed breakdowns. And if I click on it, it then allows me to then go right into it and start digging down deeper. And again, we can see the traffic sent, when we've first seen this, when we've last seen it. We can rename it, and we can trigger on this. This is top host local. And what we're looking at is all the hosts that are currently local with a little bit of graphs that show us sort of an idea of what kind of traffic that they're pushing through. Again, you can click on these, you can take a look at it and see who's doing what, but it gives you a way to sort of visualize that. You can look at a tree map, interesting way to look at who's doing the most traffic. The other way you can look at it was a local matrix. And this is sort of an interesting way here. You can look at what this host is interacting with this host. And I'm going to put my spotlight on here. You can see like here, interacting with this one, sending and receiving. Down here you can see that he's sending. So it gives you a little bit of a matrix of who's talking to what. And I'm going to show you another way, which is interactions. And this is sort of a little bit of an eye chart, but it gives you a feeling for who's talking to all of these particular nodes. So you've got some end leaf nodes, and then you've got some branches and trunks down here. And it gives you a feeling or an idea of what is sort of some of the core devices and where that's all coming from. And it allows you too to see if there are a lot of devices concentrating all their traffic onto one device. Okay, so let's get into generating some web traffic. So right now you'll see here that we're sitting at about 300 with about 300 packets, 200 packets per second, and we're about to initiate the denial of service onto the web server. So we have what is called the hacker web server, and we're going to basically run these concurrent downloads and just beat the heck out of this thing through different ports and whatnot. So in a second you're going to see this thing skyrocket, and then we'll go through and be able to show you from the hacker's perspective, from the web server's perspective, and then from the total server's perspective. So right here you can see this thing is totally hit. Hacker going to our web server, right here. This is the main thing, and look, we now have 35,000 packets per second. You'll see too that we've started to actually put a little bandwidth on this little graph, and you'll see that here we start to see some traffic that's sustaining. You can click on these here and take a look at this particular hacker, and you'll see before that the hacker was really doing nothing. You'll see with this shaded area down here, the light yellow is really nothing. And up here is where we're hitting it hard. So when you start to look at this, you start to see that there's some pretty deep traffic going on. And one of the first things you got to start thinking about or seeing is we're starting to see some alerts come in. We're starting to see some alerts come in for this particular system. So it is seeing floods. Now, if we want, we can go and take a look at the web server side of things. So I'm going to plug in the web server. Now you'll see on the other side of this, you'll see that this started to receive a whole bunch of traffic. So if I click on this, you'll see the kind of traffic that it was receiving, the sent traffic, the received traffic. Remember, we were downloading all this information from, hacker was downloading all this information. If I go into the packets and I go into the ports, but really what we want to do is let's take a look at that historical data, and you'll see that huge spike right there. So sort of for the last 10 minutes, 1 hour, there wasn't anything going on until we had this huge spike. And we should be getting some errors and all sorts of good stuff like that. Let's go into this. Let's say that that was too much for us. We now have historical data for our devices, and we know the sort of normal baseline bytes or DNS or packets that we should be getting. Here you'll take a look too that we've got alerts coming up, we've got flows going crazy, and we have all of these alerts coming in here. But here's where you can start to say, you know what, I need an alert that says that if over 1 minute Every minute, if I get 10,000 packets, I want to know about it. If I get P2P traffic, if I get a DNS denial of service, I want to know about it. And this is where the power of this sort of appliance comes in. Is it's not just going to identify or show you some of the traffic, but it's going to be able to alert you so that you can take remedial action on it to fence off that particular IP address, load balance, fire up more virtual appliances or whatnot. With this periods of time, you can say, hey, look, we're going to allow a peak. So I want it to be every 5 minutes if it goes up to that, or every hour. Because every once in a while, there may be a little quick hit. So that's where this sort of configuration is set in. You can do that, again, on the sort of local side. We're doing it on our web server right now. But if you do it on the hacker side, you can also say, I want to set some alarms on this one because I don't want this person to go over. If I see this troublesome, if I see this remote office using traffic daily over 5 gigs, I know that they're starting to do their backups out to the iCloud and they're not doing it on our internal. This is one of those items too where you can save some money by identifying trouble areas where people aren't pushing traffic the right way. Before we were looking at individual nodes, or source or destination, but now we're going to look at it from give it to me all, show me everything that's been going on. So you'll see here a few days ago we were practicing for this, getting some of our hits for the denial of service, and here you can see where we did a web denial of service. We secretly threw in a little SYN attack here, and you can see some of the top senders, the top receivers, and you can click right on them to see what the heck's going on. I want to see how much Gmail we've been doing. I want to see how much Gmail we've been doing over the last 12 hours. I would like to see how much SNMP we're doing. SNMP is a protocol that is used in monitoring devices, and sometimes people monitor the heck out of their devices almost too much, where you've got 50,000 calls going to every device times 1,000 devices, and you end up picking up your network with monitoring. So it's good to know what's going on. Other thing, let's look at syslogs. How much syslog traffic is coming through? We just installed Splunk. We just installed OP5 log server. How much traffic's really going across there? And that's where we can see this. You can even look at the protocols here. And again, this is total since startup. This is a nice way to just go through and see who's using what and who's hitting. We'll look at the size of the packets that are coming in. And keep in mind too that we can have more than one interface. We can have combined interfaces as well. I have 2 routers that are plugging into this one, and I want to aggregate that traffic together, and I want to call that the green zone. I have 2 more routers that are on a spanning port. I'm going to call that the red zone. Well, my interfaces can show a virtual interface of the red zone and the green zone, and we can look at that traffic like that. We can also pull up historical traffic as well to go backwards to take a look at something that was before the current flows that are going on. This is a great tool to identify traffic, to alert on traffic, to do some root cause analysis as to what's going on and who's talking to what and where and how much. These appliances are ready to go out of the box. I'm going to go back to the presentation here. I'm going to go through the wrap-up to talk about 3 really important things. The first thing with this kind of appliance is how can we tap in or span into your network stream, right? People say, hey, I want to know what's going on. Well, that's great, but how do we get into it? How do we sort of get a copy of that traffic's going on? And either it's a physical tap or a spanning port. And then we want to figure out who's doing what in your network, both internally, just from a green zone, or from a denial of service on the outside, and then let's figure out how to alert on those problems. And again, easy to use, ready to go appliance, right out of the box. Telcos love this thing. Denial of service is one of those things that's happening to everybody. It can be a quote-unquote easy thing to shut off a denial of service, but learning that one is going on, identifying exactly who and what and where they're doing the denial of service isn't the easy thing, and this appliance helps with that. Thank you again to everybody that's on the line, to Jim FISPA again for having us. We love talking about monitoring. Thank you again.